Good morning, my dear students. So again, I am going to solve the problems on balancing of reciprocating masses. That is secondary balancing in line engine. Okay. So last class we solved one problem. So similar type of problems again I am going to solve in this PPT. Okay. So now here question is given. So I will read out the question. Okay. The piston of a four-cylinder vertical inline engine reaches their uppermost position, that is a position at 90 degree interval in order of their axial position. Okay, so pitch of the cylinder is given 0.35 meter and the crank radius is given 0.12 meter. Length of the connecting rod, that is L, is equal to 0.42 meter. Okay, the engine runs with a speed of 6600 rpm. If the reciprocating parts of each engine has a mass of 2.5 kg, find the unbalanced primary and secondary forces and the couple. Okay, take the central plane of an engine as a reference plane. Okay, so this is the given, they given the four engine cylinder. Okay, the four cylinder. Okay, so they are interconnected with the 90 degree and they are given the what connecting rod length, speed is given and the length is given. Okay, to calculate the what the unbalanced primary forces and secondary forces induced in the slider crankback, and it is a given system. Okay, so first step is what, write down the given data here. The r is equal to what, that is the crank radius is given 0.1 meter. Okay, so in some problem they may give you in mm, you have to convert into meter. Okay, here in this problem they given direct meter only, so take as usual. Okay, so that is crank radius is equal to what, the r is equal to 0.12 meter and the length is equal to they given 0.42 meter and the speed 6000, that is a 600 rpm, not 6000. Okay, 600 rpm, and mass of the mass of each is what they given 2.5 kg, and the oblique ratio, that is a n is equal to L by R, that is connecting length to the crank radius. That is, if you divide that 0.42 divided by 0.12 is equal to, you are going to get 3.5. Okay, so you have to, what we did now, so read the question. So this is about the problems on reciprocating balancing type. Okay, so that you note on the given data, that is what they may give you: connecting rod length, radius, crank radius, speed, mass, n, l, r. Okay, you have to calculate. Okay, second step is what, the based on the given diagram you have to construct the plane of position. Okay, so here they given the four cylinder. Okay, take the draw on horizontal line, that is axis of the shaft, upon which they given the four planes. Okay, 1 2 3 4. Okay, so they given what, in order to find the axial position of the pitch of the cylinder is 0.35, crank radius is given 0.12 and length is given 0.42. Okay, and they given the pitch of the cylinder, that is the length is given 0.35. Okay, so each length between the planes are given 0.35. Okay, so 1 to 2 distance is 0.35, again 2 to 3 is given 0.35, and 3 to 4 distance is given 0.35. Okay, so also along with that they given also they given to take the central plane of an engine has a reference plane. Okay, so in a central plane is what, 2 and 3, in between that exact middle we have to consider as reference plane. Okay, so that put a dotted line here, central plane. Okay, so 2 to 3 length is 0.35, if you divide by 2 you are going to get 0.175 meter. Okay, that you have to denote there in the position of the plane. Okay, so angle 2, this is about the figure A, and figure B is what, they given the four cylinder, that is 1 2 3 4. So in between them angle is what they given 90 degree. Okay, 90 1 to 2 angle is 90 degree, 2 to 3 is 90 degree, and 3 to 4 is 90 degree. So remaining automatically, that is 90 degree with a rotation, that is some they given angular speed omega. Okay, rotated in what, clockwise direction. Okay, so once you finish this problem I'm going to solve by graphical method. Okay, so this problem can be solved by analytical method and graphical method also. Okay, so graphical method I'm going to solve that. The first case is what, unbalanced primary force and the couple. Okay, so to calculate this we have to what, you have to form a tabular column, that is plane, mass, radius, and centrifugal force, distance from reference plane, and couple. Okay, so how many planes are given here? 4 planes are given. So 1 2 3 4 write in this column. Okay, so 1 2 3 4 you write here. So second is given the mass of each cylinder is given 2.5, so write here 2.5 2.5 2.5 2.5. Okay, so radius is equal to what, the crank radius is 0.1 for all the planes is equal to 0.12 is there, so 0.12 0.12 0.12 0.12 0.12. Okay, force is, that is centrifugal force. How we are going to calculate the centrifugal force, that is mass into radius. Okay, 2.5 into 0.12 you are going to get 0.3. Okay, so the mass and radius are same, so you are going to get the same values, that is 0.3 0.3 0.3 0.3. Okay, so next one is the distance from reference plane. Okay, this is very important. So here distance from reference plane is 0 to 1. So 0 to 1 is what, 0.35 plus this 0.175, that you write here minus 0.525. Okay, from the reference plane right hand side you are going to take the negative value, right hand side you are going to take the positive value. Okay, so again reference plane to 2 is what, minus 0.175. Okay, again reference plane to 3 is what, 0.175, right here positive. Okay, again reference plane to last fourth column, that is fourth plane, is 0.525. Okay, so once if you finish this distance from the reference plane, you need to calculate what, the couple. Okay, couple formula is what, m into r into l, that is mr into l. So force 0.3 into minus 0.525, if you multiply that, you are going to get minus 0.1575. Okay, so like that you need to calculate the remaining plane couple. Okay, that is 0.35 into minus 0.175, you are going to get minus 0.0525. Okay, so once you calculate the couple and force polygon, you have to calculate what this primary force polygon and primary couple polygon and the rotation of the crank position. Okay, so here the first diagram, that is figure A, shows the position of the crank rotation. Okay, so 1 to 2 in between angle is given 90 degree, again 2 to 3, so here 2 to 3 is 90 degree and 3 to 4 is 90 degree and 4 to 1 is 90 degree. Okay, so this is about the, based on the given data rough sketch you are going to construct this. There is no use. Okay, with a speed of angular velocity omega, that is rotated in clockwise direction. Okay, so next coming to the second part, that is called, this is very important, primary force polygon. Okay, so primary force polygon, how we are going to construct here, the 1 to, that is take the 0 to 1, so reference plane to A, distance is what, reference plane to A, 1 is that is 0. Minus 525. Okay, that is 6. Okay, so that you have to construct here, keep the point here. So from this point to this point is how much angle, that is force polygon is 0.3 is there. Okay, so 0.3 right with an angle of what, 0.3, angle is 90 degree. Again A to B same length is there, 0.3. Okay, so again B to C is again 0.3, again C to O is again 0.3. Okay, so here the angle is 90 degree, so it is a closed one. Okay, so there is no generation of unbalanced force. Okay, we are not going to put any dotted line to join. Okay, so if it is put dotted line, that creation of unbalanced primary forces. Okay, but it is the diagram is closed polygon, so they hence we are not generated any unbalanced force. Okay, the no need to calculate. This is called what, primary force polygon. Okay, coming to the primary couple polygon. So couple polygon means here take the positive value upside, negative value downward. Okay, otherwise you consider positive value horizontal, positive value left hand and right hand negative value. Okay, so this is the negative value, this is I think this is negative and this is positive. Okay, so now so again coming to this couple polygon, so my first one is minus 0.175. okay, that you have to take here the right hand side, going to take positive values here. This is the positive only, correct only. Okay, positive O2 what here I shown here, reference plane to 1, that is 0 to A minus 0.15. okay, so here is there 0 to 15, that is 0 to A is minus 1.575, that you take angle is 90 degree. Again from here to B to A reference angle is how much, the length is given minus 0.0525, that you have to write here. Again put point B, again B to C's angle is 90 degree. Okay, so length is given, that is a couple polygon is given, how much couple polygon, 0.0525, that you have to there take here. Again from C to D is given, that is 0 plus 0.157, that you have to construct. Okay, so once you construct this 0 to D, there is a no length, that is a no couple is there from to connect D to O. Okay, so that is what you put dotted line, that is called as unbalanced primary couple. Okay, that you need to calculate with the help of formula, that is the distance into scaled into that omega square. Okay, so that is what unbalanced primary couple, that is OD into scale omega square. Okay, omega square is equal to what, 2 pi n by 60, that n is 600 they given, whole square is equal to what, 1172 Newton meter. So this is about the unbalanced primary couple, you need to calculate what they are asking, so you have to calculate this. Okay, so unbalanced primary couple is equal to what, 1172, that is 1172 Newton meter. So this is about the primary force polygon and couple polygon. Similarly, you have to calculate the secondary unbalanced secondary and force and secondary couple. Okay, so that you need to construct like this. Okay, so unbalanced secondary forces and couple is equal to what, same. Here you have to take the multiplication of 2, that is theta is given 90 degree, you have to multiply it into 2 theta, because formula is there 2 theta. Okay, so So theta is 90 means 180 is equal to what? 1 to 2 is 180 degree, 3 to 4 again 180 degree. So again the position of the plane is what here the given. So 1 to 2 is 180 degree, just with an angle of that same 190 degree, and 3 to 4 is also 180 degree. So again you are going to get the close one only. So angle of rotation is 2 into theta, just to multiply 2. Okay, so it is there, we already derived that equation. Okay, that is about the figure A. Coming to the second figure B, secondary force polygon is equal to what? So again here also same. So secondary force polygon they given, take this values, 0.3 is there, reference plane to 1.3, angle is 90 degree. Okay, again you are going to get 90 degree only. So 0 to 1 is 0.3, 90 degree again. Okay, so again 1 to A, so A to B is what? That is A again, that is 1 to 2 is over. So 1 to 3 is again 90 degree, so that you are going to take the top direction. Okay, that is also force value is what? 0.3 only. Okay, so here the two values going to get positive and two values you are going to get negative. Okay, so here observe here the positive and negative. Okay, two top side and two down side, so you are going to get this equation. Okay, that is what this secondary force polygon. Okay, so that is what figure B shows. Okay, so coming to the figure secondary couple polygon, so here also same. So secondary couple polygon also, that is 0 to A, that is reference plane to 0 is you are going to get positive values, that is 0.1575, 90 degree. Again 1 to 4 positive values, 0.1575. again that is what? D point. Okay, so whereas B and C negative values there, that to take the top side direction. Okay, so that is about the figure C shows, that is about the secondary what? Secondary couple polygon. Okay, so here you need to calculate the unbalanced secondary couple is equal to what? OA. So OA distance you have to measure, O to A into plus A to D minus OB minus OC BC into scale into omega square into n. Okay, so this is the omega square n you have to consider in the second, that is what in secondary unbalanced secondary problem. Okay, so we have the omega formula, that is 2 pi n by 60. Okay, so just to measure you are going to get 6.3 plus 6.3 minus 2.1 minus 2.1. Okay, if you substitute all the values you are going to get unbalanced secondary couple in this equation is 236.87 Newton meter. So like that you have to calculate the multi-cylinder inline engine problem. Okay, so I hope you understand this type of problems. Okay, these are type of problems are very very important. Definitely they may ask you in the direct in the examination. Okay, direct question, 14 to 12 mark question. Okay, so I hope you understand this. Okay, thank you.